hate them with every ounce of will and power in their body. All right? Because proofs are not really like what we're used to in math. So typically what we're used to in math is I give you something, you put it into a formula, or you have to do some equation or whatever and get an answer. Proofs aren't like that. Proofs are more like when I told you guys when you're building a court case for a murder trial. You got to have all the evidence, you got to have it sequenced together, and you're trying to prove something. So, proofs are a lot of logic. So, unlike what we've been doing in math, which is more concrete stuff, proofs are pretty abstract. All right? With proofs, it doesn't really matter how you go about proofs as long as you can justify what you're doing. All right? And where they get tricky is that you really cannot make any assumptions unless you have enough information. All right? So like we were talking about earlier in the congruent triangles unit, you cannot make assumptions unless you have enough information. So what you'll see in proofs is that a lot of statements, previous statements will kind of help you build the next statement. All right? They connect. All right, so you had two different papers that I gave you guys. The first one, I gave you guys a little cheat sheet to help you out a little bit with proofs. So that gold graphic organizer that I gave you guys, we're not going to fill anything out, but this is just a list of some of these statements and reasons that you will give on a proof. So there are two types of proofs. There's a flowchart proof, which you guys have seen on your delta math already. So do you guys remember on the congruent triangle delta math where you had like those boxes and then they had arrows? So like wherever the congruent triangle was, do you guys remember that on your delta math? This is called a flowchart proof. The other type of proof is what's on your packet currently, which is called a two-column proof. They're pretty much the same thing. You can write a proof either way. They have their advantages and their weaknesses. So flowchart proofs are good for seeing how statements connect to each other. All right. Whereas two-column proofs is more of if you like to see a linear progression. All right. Now we're going to focus more on two-column proofs because those will probably be the ones that you will see a lot more in newer classes. So, we're only spending one day on proofs, and you will have, and they will be included on the similarity quiz. All right, but because similarity is a really, really short unit, I'm predicting we'll be done by the end of next week with it. All right, so proofs will be on it, but I'm more focused on can you do a proof or can you at least logic your way through it? More so of are you perfect with them? Because you will see proofs again. You will see them again in Math 3, but with quadrilaterals. How do I know? I also teach Math 3, and I've done it 1,000 times. All right. So just know that you will see these again. That's why we're not spending a whole bunch of time on it. I just want you guys to at least be familiar with the structure and how they work. All right. So I would keep this yellow sheet out because it's going to be a good reference as we're going through these. All right. So let's look at the very first page of that packet. So I separated this from the similarity packet because it's kind of just a monster in and of itself. So I just wanted it by itself. Still, technically, if we did Unit 2A like we're supposed to, this would have been 2.5 on Unit 2A. But technically, Unit 2B starts with 2.6, so you can put it anywhere. All right. So let's look at this very first proof. Now, we're going to start with proofs where they already gave us all the statements. So the way that a two-column proof works is that you have a statement, which is what we are saying. So in other words, we're saying that these two sides are congruent, these two angles are congruent, these two angles are supplementary, these two sides are parallel, whatever. These two triangles are congruent. The statement side is the what. What are we saying? The reason side is the why. All right. So that's where all those properties come in. So reflexive property, which we talked about earlier this week. All the triangle congruence postulates, those will come into play with these. CPCTC, so congruent parts of congruent triangles are congruent. All the parallel line theorem ones, they're all going to be seen or can be used with the reasons. All right, so the statements are the what, the reasons are the why. All right, so you can think of the reasons as your justification. Like, I know this because, or I know this to be true because. So, my suggestion, whenever you start a proof, how they usually start a proof for you is they give you something that's true about the picture. All right, so that's called our given. So our given statement is right here. They don't just tell you prove these triangles are congruent and have at it. No, they give you something to start with. That's typically how proofs start. So they said given DA is congruent to DC and B is the midpoint of AC. So my suggestion, go ahead and mark it. So DA is congruent to DC and B is a midpoint of AC. Now, what they want us to actually prove is usually stated below it. So it said prove that triangle ABD is congruent to triangle CBD. So we're proving that that little triangle is congruent to this little triangle. Now, they already gave us the statement, so we just really need to figure out the reasons. But if this was one that you were doing from scratch, I always start with, you always start any proof by listing the given information first. It's always how you start a proof. So if you look, the very first statement is exactly the same as our given statement. So they said DA is congruent to DC and B is the midpoint of AC. The reason is going to be the easiest reason ever. All the reason is that it's given. So if they give it to you, if they already pre-mark it, so given can be anything from they already stated it at the beginning of the proof, or they pre-mark something for you. It's a given. All right, you don't have to come up with something fancy like, oh, these sides are congruent because of an isosceles triangle or whatever. Nothing like that. If they give it to you, your reason is it's given. Now, from there, we can go about finding the reasons for the rest of the proof. So, when it comes to proofs, typically previous statements help you justify the next statement. So if we look at the next statement, it says AB is congruent to CB. They're saying that this little segment here is congruent to this little segment here. What part of the previous statement could lead us to 2? Maxon. Right, B being the midpoint of AC. Why is that true then? So anyone, why is that true? Why is this being a midpoint helps us show that these two little segments are congruent? Allison.
It's in the middle of AC, that means the length of either side of the midpoint.
Right. A midpoint basically is halfway down a segment, so it will cut a segment in half. So our reason, since it involves the definition of a midpoint, our reason is literally the definition of a midpoint. So why is that true? Well, that's just the definition of a midpoint. Midpoint, if you have a midpoint, that means the 2 little segments on either side of it are going to be congruent. Now, they then claim that DB is congruent to itself. So this segment right here is congruent to itself. Now, we talked about this already before. what property can we say involves a segment being congruent to itself? So, A, the reflexive properties. That's literally our reason for this next one. Those two are the same because of the reflexive property. That's why I was trying to drill that one in your head last week, because you're obviously seeing it again now. Now, why I tell you guys to mark these as you go is because now we got enough information to prove what we want to prove. So your last statement should always be what you're trying to prove. So the last statement should always be what you're trying to prove. Now, since we're proving that two triangles are congruent, our reason is going to be one of those 5 congruence postulates. So side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Based off of what we have marked, what postulate do you think proves that those two baby triangles are congruent? Richard? Side, side, side. Good. So that'll be our reason for 4. Just side, side, side. That's why it's congruent. Yes, sir.
Do you need like a statement for each one? Like the first one has B and C.
So sometimes if it's like, if the reason is the same, they'll put them together. But you can also separate it if you want to. All right. So like, for example, in delta math, the only time that they combine two statements is if it's the given. All right. But every other statement you would have to break apart, even if it's the same reason. But if you were writing a proof, like, for example, let's say that there were 2 midpoints on here, all right, for whatever reason, and we knew that they were midpoints from the given, we could state that those 2 baby segments were congruent by definition of midpoint, and we could list that in the same spot. All right, if we wanted to. Does that kind of answer your question? All right, so let's try another one. So, different picture. We're going to start, but now they gave us all the reasons. We got to figure out the statements. All right, so we're doing the reverse. So, let's start first with just what they give us. So, they say that EH and FI bisect each other. So, they're saying that this segment and this segment bisect each other. They're not congruent, they bisect each other. And they want us to prove that those 2 triangles are congruent. Now, our first reason is given. So what obviously is going to be our statement? Right. It's going to be exactly what the given is at the top. So we're literally going to just copy that yellow statement up top. So EH and FI bisect each other. Now, remember what I said, more often than not, your next statements are going to be coming from the previous statement. So it's going to be something that you take the first statement and that'll help you conclude the next statement. So our next reason is that it's a definition of a segment bisector. So what does segment bisector mean? So it's similar to an angle bisector, which we have talked about before. So what's an angle bisector? What's it do? It's also on that gold sheet, guys. So segment bisector is on that gold sheet. What does a segment bisector do? Or what is it? Kind of. You're on the right track there. That's not quite what I'm looking for. So think about, so those of you who missed beginner's Latin class, think about the root of the word 5. What does 5 mean? 2. So if we're saying that these 2 segments bisect each other, what do you think they do? They cut each other in half. All right. So it's going to be similar to a midpoint. So what that means is that point G, where they intersect, would actually be the midpoint of both lines. So what does that say about the segments themselves? What can I say then? FG equals IG, and EG equals HG. So this is one of those where we can state two statements in one because it's the same thing. So we can state that segment FG is congruent to segment IG because of that's the definition of a segment bisector. And we can state that EG is congruent to HG because again, that's the definition of a segment bisector. So that's another thing about proofs. They're very vocab heavy. Now, I gave you that reference sheet for a reason, so it's a good way for you to practice. Because most of your statements and reasons that you'll see on these types of proofs will be on that sheet. All right? That's actually something that I use in one of my math classes. So I just ran it off the page. All right? Now, the next the next reason states vertical angles theorem. So that's pretty self-explanatory. If we're talking vertical angles, what do you think my next statement's going to be? Yes. So we're talking about the vertical angles, which are right here. And we know vertical angles to be congruent, so angle EGF is congruent to angle HGI. Now, the last statement is easy because it says it's now proven by side angle side. So obviously our last statement is going to be what we're trying to prove. So triangle EGF is congruent to triangle HGI. So that's how you end a proof. You always end a proof with what you're trying to prove. If you don't, then it's not going to be correct. Your last statement should always be what you're trying to prove. Now, let's take this a step further. Let's say that instead of proving that these two triangles were congruent, let's say that I was also trying to prove that EF is congruent to HI. Using what the proof that we already have, all I would have to do is add on one more statement to prove this. So this is just the hypothetical, so I'm just going to draw a line here just so you know it's hypothetical. But I'm showing you this because you will see one like this. All right. I can now say that those two segments are congruent. Why? Someone raise their hand and tell me why, Odin. Right, because the triangles are congruent. What's the specific name for that reason? Not quite. It's an acronym. CPCTC. So your reason here would be CPCTC. Corresponding parts of congruent triangles are congruent. So Odin, what you said was correct. I was just looking for the actual acronym. All right, so just know if you see something like that where they asked you to actually prove that two segments were congruent, prove the triangles are congruent first, and then you can claim the rest by CPCTC. Does that make sense? All right. Now, let's try one where it's kind of a mix of what we're trying to find. So this next one is they gave us some statements and some reasons. So we're either trying to find one or the other. Now again, always look at your given statement first and mark it. So my rule of thumb is mark as you go. All right, because if you don't, especially since we're proving triangle congruence, when you get to that last statement, it's going to be pretty hard figuring out what the postulate is. All right. So first things first. Who remembers what this symbol means? Parallel. So they're saying JM is parallel to LK. So if I'm marking this on the shape, what is the tick notation that I mark on that shape? Right, little arrows. So we're going to put JM is parallel to KL. I'm going to use the little arrow ticks. They also said that JM is congruent to KL. So I'm going to use my singular tick. What would be the reason for that? Because that's our first statement. It's what? It's given. They gift wrapped that sucker for us, so we're just going to say it was given to us. Now, the next one, they only gave us a reason. They stated alternate interior angles theorem. Now, think back to congruent triangles, the last unit. If we're talking alternate interior angles theorem, what do you think we're actually going to be stating? We're going to be stating two angles are congruent. So, now, what part of the previous statement can help us figure out which angles they're talking about? So what part of the previous statement connects to this reason? Right, that these two lines are parallel. Okay, so if it helps, you can always extend the lines a little bit. Because sometimes it's a little bit hard to see when it's just in a shape, but if you want to, you can always extend the lines. So if you think about it, those are our two parallel lines, and this diagonal right here is the transversal. So if we're talking about alternate interior angles, which two angles here would be the alternate interior angles? It's not J, not LJ. Okay, let's do it this way. This is kind of help us. What's your numbers? Nope. It's 2 and 3. All right. So 1 and 4 is technically not alternate interior. Just because it's right where the vertex is, where it crosses the parallel line, it's not actually an angle created by the parallel line.
What if you just extend the parallel line?
Say again?
What if you just extend the parallel line?
I'm sorry, say that.
What if you just extended the parallel line?
Well, even if we extended it, if you look right here, this angle is made by, it's touching the parallel line, but it's not made by it. It's not one of the sides. This angle is. Now, if we said these two lines are parallel, then yeah, 1 and 4 would be the alternate interior. It's a very fine distinction. So, now that we know where they are, how do I name them? So we know these angles are going to be here and here. So how do I name them? LJM. LJM is congruent to, I would say, JLK. And again, they're congruent because they're alternate interior angles. Now, the next one, they gave us a statement. They said that JL is congruent to itself. So automatically, that's what property? Reflexive. I do love some reflexive properties because that's always nice when you can because you can literally say anything is congruent to itself. Even if it doesn't even if it's not applicable to the proof, you can still say it. All right. It does help when you get to some of the harder proofs because a lot of times what happens is you'll use it for some substitution stuff. Which again, you won't really see until max 3, but just something to think about. All right, so now they said that we have enough information to say that the triangles are congruent by SAS, side angle side, which is true. So we're just going to state what they wanted us to prove. The triangle MJL is congruent to triangle KLJ. And we're done. Take a minute. Try number 4 on your own. So take a minute. Try number 4 on your own. So I'll leave this one up just for some reference. It's not quite the same, but it's close. So use that graphic organizer if you need it, because that can help you come up with reasons and it can help you come up with statements. I'll give you a hint. You're looking at that graphic organizer, you're saying, like, if you know the statement is this, the reason usually is right next to it on the graphic organizer, vice versa. So the reason is this, what you're looking for, the state. So so they're trying to so all they're using the graphic organizer. So you always have to do this. So it goes to change. And from there, you can start with assumptions based on what you're given. The goal is to prove that those two terms are correct. So the statements are the point, the reasons are the point. So it's a good one to discover. Yep. You would literally just you would literally copy this entire statement yourself. Thumbs up if you're ready. All right, let's go over this. All right, so always start with your given. And I'm going to go ahead and mark everything. So they said that JM is congruent to JK. So these two sides are congruent. And that would help. Yeah. They also said that side JL bisects this angle right here. All right. So our first statement says it was given. So what do I put for my statement? Anyone? Literally just the exact same thing. So you just got to copy that given statement. So JM is congruent to JK, and JL bisects angle MJK. Now, remember what I said. The next one, they gave us the statement, but not the reason. Remember what I said. They tell us things for a reason, or we come up with things for a reason. There's always a connection. So, what part of the given statement do you think is going to help us show that these two angles, which are MJL is here and KJL is here, that those two angles are congruent? Well, JL bisects MKJ, so Allison, what does that mean?
If it's split that angle in half.
Right, because it bisects. Bisects means cut in half. Just remember that. Bisector, bisects means cut in half. All right, so what would my reason be? Anyone? Definition of angle bisector. That's literally what it means. It's the definition of an angle bisector. Now, the next one, they gave us a reason, which was reflexive. They said reflexive. You could also say reflexive property, whatever. All right. And we know the reflexive property means that it's some side or angle congruent to itself. All right. And what's the only one that would be applicable in this proof? A. JL. Correct. So we would literally just say JL is congruent to JL. So if you're saying that something's congruent to itself, you're literally just going to state like JL is congruent to JL. So now we can show that those two little triangles are congruent. And since we've marked everything, what postulate lets us know that those two triangles are congruent? So it's not side, 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 but it's side, angle, side. All right. Try number 5 on your own. So this one, they gave you all the statements. Now they just want you to get the reasons. So in my opinion, coming up with the statements is a lot harder than coming up with reasons. So they gave you the statement. Now come up with the reasons. Essays. guys if you are happy with that one and it's going to move on to the rest of the better you get at it, the better you will be at it on your own. They're the same because they are. Thumbs up if you're ready. All right, let's go through this one real quick. Okay. So obviously the reason for the very first one would be what? So they said that these two lines are parallel, these two lines are congruent. Thought I unfroze it. Dang, blab it. So what's obviously the first reason given? They then said that this angle was congruent to this angle. What would be that reason? Right, alternate interior angles are congruent in parallel lines. Now, if you couldn't see that, by all means, what might help is if you turn your paper, because then the orientation will look more like what you're used to. All right. But just remember, there's always going to be some connection to the previous statement. They then said that these two angles were congruent. Why? Vertical angles are congruent. So, what would they be congruent by? What postulate? Angle, angle, side. Good. All right, so here's what we're going to do next. I want to do a little bit more practice with this, but I actually want to see if you guys can do some ones where you actually have to come up with the statements and the reasons. So what I want you guys to do is take out your Chromebooks and log on to Delta Math. We're going to do a couple together in Delta Math. Yes. You left it where? Go get it. So when you get into Delta Math, you're going to go to the one labeled 2.5. It's 2.5 triangle proofs, but don't do anything else until I tell you to. So log on to Delta Math and go to the assignment labeled 2.5 proof. So we're going to do a couple of these together as a class. Everyone log on to Delta Math. Don't do anything just yet. We're going to be doing some of these together. Yes. Is everyone on Delta Math? Give you guys another minute. If you are on Delta Math, we're going to be starting with the very first column that says triangle proofs reorder steps. So it's not going to be the first topic. It is 1, 2, 3. It's 4 down. It's the one that says triangle proofs reorder steps, the first one. So everyone should have the same problem. It looks like this. So it's the one that says, so it's the 2.5 proofs Delta Math, and then it's going to be the one that says triangle proofs reorder steps in parentheses, the first one. So everyone should have this exact same problem. So the given and the proof should be exactly the same. Is everyone on this problem? So you guys aren't doing anything on your own yet. I want to do this together.
How do you get there again?
It's called triangle proofs reorder steps or in parentheses. Is the first one. Now, this one, they gave us all the steps and the reasons, but we have to reorder them to make logical sense. All right. So I'm going to zoom out a little bit because everyone should have the exact same thing on their screen. So if you can't quite read it, that's okay, because it's going to be the exact same thing on your screen. I just want to zoom out just so we can see everything. It's the fourth one down. All right. So they said, given that triangle ADE is congruent to BDE. Now, here's the nice thing about Delta Math. If you hover over the statement, it actually highlights what it's talking about. All right. So if I'm hovering over triangle ADE is congruent to itself, see how it's actually highlighting it? All right. And they want us to prove that ACD is congruent to BCD. So, based off of what we already know about proofs, we can already figure out what our first and last statement is. What has to be our first statement? The one that says given. So, it's already at number 1, so we're good. What has to be our last statement? Whatever it says to prove. So it says that triangle ACD is congruent to BCD. So I got to take number 4 and move it down all the way to 8. So it was originally at 4, move it down all the way to 8. So grab the number and just drag it down. No, this should be the one that should be at the bottom. Oh, yeah, it's 5. My bad. I grabbed the ankle one, not the triangle one. There we go. So that's our final statement, that those two little triangles are congruent. But now we got to work our way down. So look at the statements and look at the reasons. So let's start with what we're given. So we're given that two triangles are congruent. So we're shown that these two baby triangles right here are congruent. So if we're trying to prove that these two triangles are congruent, which of these statements would make the most sense to go first after the given statement? So think of a statement that would connect. So you could put the reflexive property. All right. You could put that there because that'll give us one side that's congruent. Now, I'm thinking of something else that's connecting the very first statement to what we're trying to prove. How can I use the first statement, so the given statement? Which other statement on here connects to the given statement? So it'll be what? Right. AD. Not those two just yet. AD is congruent to BD. So those two segments are congruent. I would state that after because of CPCTC. So if you already have two congruent triangles, you can start saying that sides and angles are congruent because of CPCTC. What else? So I would actually leave this next statement where it is, number 4. So angle ADE is congruent to BDE because of CPCTC. Because then, and this actually moved around so that it's actually in the correct order now. So this is actually in the correct order now. Why? Right. So once we prove that these two angles are congruent, we can start to get to where these two angles are congruent. Then we can show the triangle congruent by side each side. We already have a congruent side here, corresponding set of congruent sides there. So now we just need the angle. So number 5 statement says that these two angles are supplementary, and it's because they're linear pair. Same thing with the angles on the other side. So we can say that those two angles are supplementary because they are supplements of the same angle, because we already said that those two baby angles are congruent. So if they're supplementary to each of those individual angles, that means they have to be the same size. Does that make sense? And thus we have enough to prove those triangles are congruent. So we can submit that. Now, that was one where we just had to reorder the steps. Now let's try, and I'm going to do this from back here because my computer is about to die a horrible death. So now we're going to try one where we actually have to come up with it on our own. So I'm going to hit back. I'm going to the one that's labeled Triangle Proofs Level 1, the very first one that states that. So Triangle Proofs Level 1. On my end it says single, but on your end it'll just be the first one that says Triangle Proofs Level 1. All right, so click that one. This should be what your proof looks like. Now, the nice thing about Delta Math is they already input your given statement, so you don't have to do that. So now we just have to go about proving that those two angles are congruent. So I'm trying to prove that BAC, so this angle right here, is congruent to this angle right here, DCA. So let's just come up with a plan of attack. What do you think we're going to have to prove first before we can prove that those two angles are congruent? What have we been proving all day? We've been proving that the triangles are congruent. So we have to prove that these triangles are congruent first, because then we can show that those two angles are congruent by CPCTC. All right, that's usually the plan of attack. If they ask you to prove some angles congruent, prove the triangles are congruent first. So now, let's just list some things that we know. So what's one thing that you guys absolutely know based off of the reflexive property? So what would I say? AC is congruent to AC. So I'm going to go to the statement type, and you're going to click on the one that says two segments are congruent to each other. And you're going to type them in. Make sure you use capital letters because they're picky. So AC is congruent to AC. Why that is? Because it's the reflexive property. Now, the nice thing about this is it doesn't let you move on if you don't put in a correct statement. So if you hit try, if it takes it, it works in the proof. If they tell you it doesn't work or you don't have enough information yet, then that means that you have to prove something else first. Now, they gave us some given statements for a reason, so let's use them. So we now have two sides that are congruent. What is one thing that I can prove now to prove that the triangles are congruent? We can prove some angles are congruent because we know that these two lines are parallel. So we can use some alternate interior angle stuff. So what two angles here would be congruent based off of alternate interior angles? So CAD would be congruent to what? BCA. So we're going to go to statement type, click the one that has congruent angles. We're going to say BCA is congruent to DAC. Now, Delta Math is very, very, very picky about corresponding. All right. So make sure that you have those corresponding sides and angles together. Why it's true? You're going to scroll down until you see parallel lines cut by a transversal form congruent alternate interior angles. Make sure it says interior because they have an exterior too. Hit try, it takes it. Now, we need to ask ourselves, do I have enough information to prove that these two triangles are congruent? Yes. So I can now take a statement, go down to the one where it has congruent triangles. How would I state it? Triangle what? BCA is congruent to what? Think about corresponding sides. DAC. So BCA is congruent to DAC. How I know? Well, since I started at B, that looks like it's a bigger angle. So I have to start at D over here, which looks like it's a bigger angle. Then I went to the one that's marked, and then to the one that's unmarked. Same thing over here. You go the one that's marked, one that's unmarked. What postulate tells us that? So what's the postulate here that tells us that? Side angle side. Now, we now know that these two triangles are congruent. So now do we have enough information to state what we're trying to prove? Yes, we do. So we can now say that what we're trying to prove, so angle BAC is congruent to DCA. Why? CPCTC, which is right here. Corresponding parts of congruent triangles are congruent. Now, when you hit try and it doesn't give you an option to fill in anything else, then you're done, and then you can submit it. So that's nice about these. They're kind of already self-checking before you even submit them. So if I hit yes, it takes it. Now, that was a relatively easy proof. Nice little baby proof. Let's try one that's a little bit harder. All right. So I'm now going to go to the one that says triangle proofs level 2, the very first one that states it. So triangle proofs level 2. So it should look like this. Now, this can be a little bit more difficult because what's it asking us to prove? It's an isosceles triangle. So they're trying to prove that this middle triangle right here is isosceles. All right. Now, they already gave us some information. So they said that these two sides are congruent and these two angles are congruent. So since they told us that, what do you think we're gonna have to do first? So they've already told us some things are congruent. So typically if they tell us some things are congruent, what are we typically proving? Congruent triangles. So I would start by proving that these two triangles are congruent, those two little triangles. Now, here's how we can go about this. I would start, if this was me, there's no direct link to connect any of these other sides. All right, there's no direct link to connect these two angles right here. But there is a connection for angle A and angle C. Why? How can I show that angle A is congruent to angle C? Abby. Okay, Colden. Well, they're on the same base, but that doesn't necessarily mean that they're congruent. Fisher. It's not reflexive because they're not in the exact same spot. Reflexive means exact same spot. So, for example, this little angle right here, the one in between the two congruent angles, we could say that that is congruent to itself because of reflexive property, but we don't need that. They're opposite congruent sides. So, in other words, this big triangle is a what? It's an isosceles triangle. So we actually got to state that this is an isosceles triangle first before we can say that those two angles are congruent. All right, because even though they're across from congruent sides, that's still not enough information. We got to show that this is an isosceles triangle first, which we can because it's a triangle with two congruent sides. So we're going to go to where it says classify a triangle. And we're going to say a triangle BAC, so this huge triangle right here, is an isosceles triangle. Why? Because we have two congruent sides. If we try it, it takes it. Now, we can say that these two angles are congruent. So I'm going to say the triangle angle of the actual triangle I'm trying to find congruent. So I'm going to say BAE is congruent to BCD. So angle BAE is congruent to BCD. All right. So, and why? It's because an isosceles triangle has two sets of congruent angles, and there should be one like that. I just got to find it. In a triangle, angles opposite congruent sides are congruent, or you could also say, no, it's this one. So angles opposite congruent sides are congruent. So in reality, we probably didn't need to state the isosceles triangle, but sometimes covering your butt is a good thing. It's not going to count you wrong if you do more statements or reasons than what they originally expect you to do. Now, do we have enough information now to show that these two baby triangles are congruent? Yes. So now I can state that triangle BAE is congruent to BCD. By what reason? It's what? ASA, angle side angle. Now, why did I go through the hassle of proving that those two triangles are congruent? How does that help me show that BED is an isosceles triangle? Because now we can use CPCTC. Where would I use CPCTC? What part? BE is congruent to BD. So I can say that BE is congruent to BD. Why? CPCTC. So that's why proving congruent triangles is great, because once you prove that the triangles are congruent, you can prove that any side or angle in those two triangles are congruent by CPCTC. So now, do we have enough information to classify this triangle as an isosceles? Yes. So we're going to go to classify triangle, and we're going to say that BED is an isosceles triangle. Why? It has two congruent sides. And we're done. So in reality, it wasn't as long. It wasn't necessarily a very long proof. I've done some where they get down to like 20 statements. I've done some in college, and you guys will probably never see these unless you go to college for like engineering or anything math related. I've done some where you're actually proving algebraic concepts. So they can get, geometric proofs are definitely the easiest. I'll just put it that way. Yes. No. I just know that because I have engineering friends. All right. Any questions on this? So you got the rest of class. Your assignment is to finish this delta math. So the rest of this delta math is all yours. Also, little incentive. If you finish the packet and submit it in Canvas, which I'll put the link up later, I'll give you extra credit of some kind. So if you finish the packet and submit it in Canvas, let's say by whenever the quiz or test is, so that'll be sometime next week, and I'll tell you that date for certain. If you finish that packet and take pictures of it and submit it in Canvas, which there should be an assignment link on the assignment page, which I'll put in a minute, I'll give you guys extra credit of some kind, whether that be on the quiz or just random extra credit or something. I'll give you something. Also, guys, if you are just completely lost in la la land with proofs, please come talk to me.
Remember the ones that we did while it's gone? My computer's about to die. So it's at 2%.
Okay. So we didn't do that one. We only did this one, this one, and this one. And to be honest, if you go into Canvas, I have a video, which by the way, I need to stop said video.